Assalamualaikum warahmatullahi wabarakatuh. Hari ini saya akan present past year question chapter 5 PSPM 2011-2012 soalan nombor 1. Okey, mula-mula yang kita kena buat is cari information yang dia dah bagi dalam soalan. So kita dapat M equals to 0.8 kg, R radius dia, panjang dia kita dapat 75 cm, delta dia kita dapat 53 degree. So A1 kita kena cari work done by gravity. Jadi kita guna formula W equals to mgh equals to 0.8 times 9.81 times 0.75 minus 0.75 cos 53 degree. Okey, kenapa kita guna Hz macam tu? Sebab kita guna formula untuk pendulum. So formula dia L minus L cos theta. Jadi L yang kita dapat kat sini, line dia kita dapat 75 cm. Lepas tu kita tukarkan kepada meter, so kita dapat 0.75 meter. Jadi kita masukkan dekat dalam equation, jadi kita kira kita dapat 2.35 joule. Untuk soalan A2 pula, kita kena cari speed of the bob at Q. Kita guna formula mgh equals to 1 over 2 mv squared. Mgh ni ialah PE, which is potential energy, dan 1 over 2 mv squared ni adalah kinetic energy, which is KE. So mula-mula waktu kita sebelum pendulum tu jatuh, waktu dia ke atas tu, kita tak ada kinetic energy. So kinetic energy dia zero, kita cuma ada potential energy je. So bila dia dah hayunkan pendulum tu dekat Q, kita akan dapat kinetic energy, tapi kita tak ada potential energy. So potential energy dia zero. Jadi kita dapat potential energy equals to kinetic energy. So kita guna formula ni, kita dapat 0.8 times 9.81 times 0.75 equals to 1 over 2 times 0.8 V squared. So kita kira kita dapat 5.886 equals to 0.4 V squared. V squared tu kita bawa ke sebelah, so kita kira 5.886 over dengan 0.4, kita dapat V squared equals to 14.715. Lepas tu kita square root kan 14.715, kita dapat V equals to 3.84 ms negative 2.
Okay, so for this question, first dia suruh kita state the work energy theorem. The work energy theorem states that the net work done by the forces of an object is equals to the change in its kinetic energy. Next, disuruh cari magnitude of force. Untuk cari magnitude of force, kita boleh pakai formula W equal to Fs, tapi kita tak tahu W dia. So first kita kena cari W dia, boleh pakai formula W equal to Kf minus Ki. Untuk cari Kf and Ki, kita boleh pakai formula half mv power of 2. So kita masukkan je data yang dia bagi dalam soalan tu dalam ni, and kita akan dapat work dia is equal to 6.25 joule. Lepas tu kita masukkan je dalam formula W equal to Fs, kita akan dapat F force equal to 2.08 Newton. Selain cara ni, kita pun boleh pakai lagi satu cara, which is F equals to ma. So first kita kena cari dia punya A, acceleration. So untuk cari acceleration, kita boleh pakai formula yang kita dah belajar chapter 2, which is V power of 2 equal to U power of 2 plus 2as, and kita akan dapat acceleration dia 4.17 ms power negative 2. So kita masukkan je dalam formula F equal to ma, and kita akan dapat F dia is 2.09 Newton. So that's all.
Hello, today I am going to explain about question 3. So the question is, Figure 5.2 shows a block held at rest at the top of a 18-meter long rough slope with coefficient of kinetic friction 0.19. The height of the box on the slope is 12 meter. When released, the box slide down. So, A. Calculate the final speed of the block at the bottom of the slope. So, first of all, kita kena cari theta. So, kat sini, kita nak cari theta. Kita kan ada triangle, so bolehlah cari theta. So, theta kita akan dapat 41.81. And then, after kita cari theta ni, better kalau kita buat free body diagram. So, kita lukislah free body diagram dia. Macam ni. Okay, after kita dah draw FBD, kita tengok apa the best formula untuk soalan ni. So, untuk soalan ni, the best formula yang kita boleh pakai ialah work energy theorem. So, this is the formula. And then, kita nak cari final speed kan. So, final speed untuk ni, kita guna kinetic energy which is 1/2 mv squared. So, the problem is kita tak ada work. Kita tahu work sama dengan F net times displacement. So, kita bolehlah cari F net. So, macam mana nak cari F net? Daripada free body diagram ni, kita tengok kita tengok dia punya X component dulu. Alright. So, untuk X component ni, dia sama dengan kat sini ada W sin theta dengan frictional force. But the thing is, kita tak ada frictional force. So, kita tak bolehlah guna komponen X. So, kita kena tengok Fy. So, kat Fy, kita ada normal force dengan weight. So, macam mana nak cari komponen Y ni? Komponen Y kan total Fy equal to 0. So, N minus negative N minus W cos theta equal to 0. So, N kita akan dapat W cos theta. So, kita just substitute je lah. Semua info yang kita ada dekat dalam ni lah. So, kita akan dapat W kan sama dengan mg. So, darab terus 9.81 m. Kita tak ada mass, so biar je m ni. And then cos 41.81, and then kita akan dapat 7.3112 m. M ni biar je, sebab nanti later kita nak cancel. So, stay je kat sini. And then bila kita dah ada N, kita bolehlah cari frictional force. Frictional force kan sama dengan mu N. So, mu N, mu tu dia dah bagi dah 0.19. So, kita masukkan je jawapan ni dalam ni. So, kita akan dapat 1.3893 m. Okay, after kita dapat frictional force, barulah kita boleh buat yang komponen FX ni. So, sekarang kita dah cukup semua information dekat sini. So, nanti 9.81 m sin 41.81 minus dengan frictional force, kita akan dapat 5.15 m. Okay, after dah dapat ni, so means kat sini kita dah ada ni, S pun kita dah ada, this one pun kita nak cari this one kan, kita nak cari yang ni. So, kita boleh je lah masukkan all the information kita ada dalam formula yang ini. So, kita akan dapat F net multiply by displacement equal to kinetic final kinetic energy kan. So, this one answer yang ni 5.15 m multiply 18 equal to 1/2 mv squared. So, m dengan m kita boleh je cancel. So, kita cancel. Nanti kita akan dapat macam ni. After multiply, dapat 92.71 equal to 0.5. V squared. So nanti V akan equal to 13.6 ms meter per second. So inilah final answer kita. Okay, next question 3B. If the mass of the block is increased, will the final speed of the block decrease? Same or increase? Justify your answer. So my answer is same. This is because mass does not affect initial and final speed. So hence in our previous calculation, we can just cancel out mass.
Hi everyone, now I'm going to explain about past year question number 4. Question 4 is to find the velocity when displacement equals to 10 meter. For this question, I use the work energy theorem, which is work done equals to final kinetic energy minus initial kinetic energy. For the work done, you can just calculate the area under the graph, and after you solve this equation, you'll find that V equals to 11.51 meter per second. The next question is 4B1. Calculate the speed of object just before striking the spring. For this question, you can use the diagram that I've drawn as reference. So for this question, I use the principle of conservation of energy, which is initial total energy equals to final total energy. So question B1, this is initial total energy and this is final total energy. For this, the initial total energy consists of gravitational potential energy, which is mgh, and the final total energy consists of gravitational potential energy and kinetic energy. So for this question, I combine the mgh together to become mg times with h1 minus h2. So h1 minus h2 is actually equals to 30 centimeter, and after you solve this equation, you get V is equals to 2.43 meter per second. The next question B2 is to determine the maximum compression X of the spring. For this question, I also use the same concept as B1. So this is the initial and this is the final. So the initial total energy consists of gravitational potential energy and kinetic energy, and the final consists of gravitational potential energy and kinetic the elastic potential energy. So for this, I also combine the mgh, becomes mg times with h2 minus h3. So h2 minus h3 is actually equals to the compression of the spring X. So after you substitute all the values into this equation and you solve this equation, you find that X equals to 0.087 meter.
Hello everyone, Isaac here from Practicum 144 in KMS. Alright, this is question number 5A in PSPM 2019-2020. The question states that figure 5.5 shows a 15 kg block being pulled by 100 Newton force at an initial speed of 2 meters per second up an inclined plane. And just with that information, we can come up with a few solutions, alright? So a few clues on how are we going to solve this problem. So first up, it's an inclined plane, so let's resolve the forces. Vertically, what we get is that there is a reaction force from the surface of the inclined plane upwards. Alright, it's perpendicular to the surface of the inclined plane. And next we see the block. We know it has weight, and weight is equals to mg, so that's how I labeled it, and it's going to be vertically downwards, perpendicular to the base of the inclined plane or the surface of the earth. Alright, so resolve the weight component. What you get is mg cos theta and mg sin theta, whereby theta is equals to 25 degrees. So now by splitting this mg, what we can do is we can split the vertical and horizontal components. Vertically, what we have is we have r and we have mg cos theta. Horizontally, let's look at the question first. The block travels a distance of 6.2 meter parallel to the inclined plane. That means my displacement is 6.2. And the coefficient of kinetic friction is 0.14. This just proves that there is friction, so my friction is going to be opposite or opposing direction of motion. So that means my F is going to be downwards. Alright, so by analyzing the horizontal component, what we get is that there's a pulling force of 100 newtons upwards, and opposing it we have two forces actually. The first one is my friction, my kinetic friction. The second one is mg sine theta, whereby theta is 25 degrees. Alright, and the question states that by using the work energy theorem, calculate the change in kinetic energy of the block. So they want the change in kinetic energy delta K by using work done. So before that, if you notice, we don't have the final velocity of the block, so we cannot use W equals to delta K formula. So what I did here is I used W equals to sigma F, the product of sigma F and S, whereby sigma F is just a summation of my force, or the resultant force, multiplied by my displacement. So step 1 is to find my sigma F, which is we are only looking at my horizontal component, which is my pulling force minus my frictional force minus my mg sine theta. And so when you solve it, you come to a point where you realize that you don't have a value for the frictional force. So what do? You use the other piece of information given in the question, the value of your coefficient of kinetic friction, which is 0.14, labeled as mu. Alright, so using the formula F equals to mu r, bear in mind my F is small f because we're looking for a frictional force, and my r is going to be equal to my mg cos theta. Reason being, summation of F is equals vertically up, summation of F is equals to 0, because the box is not moving upwards or downwards, it's balanced, the forces are in balance. So r is equals to mg cos theta. So sub in the value for m and g and multiply it, you'll get the value of your kinetic friction, which is 18.671 Newton. Alright, so sub it back into your summation of F for the horizontal component, and you'll get your your resultant force for the horizontal component, which is 19.141 Newton upwards. It's going up the plane. Alright, next part is to find the work done. We have the summation of F, we have to multiply it by displacement, which is 6.2, it's given up there. And the answer is 118.67 joule. Now the next part of this is more towards the concept rather than calculation. What we know is that the work done can also be used to calculate the change in kinetic energy. And so, in other words, what we can say is that sigma Fs would equals to delta K. Yeah, that would be a shorter way to do it. Instead of separating it like this, you can straight away write sigma Fs equals to delta K, whereby delta K is the difference between my final kinetic energy and my initial kinetic energy. So just to make a small conclusion, you just write down there, therefore change in kinetic energy is equals to 118.67 joule. That's it. Alright, question B, it states that there is a 120 kg motorcycle that accelerates uniformly from rest to 25 meters per second in 5 seconds. So keyword here, we have the mass 120, accelerates uniformly, that means acceleration is constant. At rest or from rest, that means my initial velocity is 0, and my final velocity is 25 meters per second, and the range or the duration of the journey is 5 seconds. Alright, so I made this little diagram. It's supposed to be it's supposed to start at t equals to 0, but whatever, like, it doesn't affect much. Okay, let's look at this. Hold on. And so the question says calculate the instantaneous power of the motorcycle at time t equals to 3 seconds. So they want when t equals to 3. Okay, so since this is a linear motion, bear in mind that my final velocity at the 3rd second would be less than 25, because the velocity is going to be increasing and the acceleration is going to be constant. Okay, that means throughout the journey we would have the same value for the acceleration. So for t equals to 1, t equals to 2, t equals to 3, my value of acceleration is going to be the same. That gives us a clue on how we're going to solve this problem. So first up, the power formula we're going to use is the product of force and velocity, whereby the force is just for my motorcycle and my velocity is going to be the velocity at t equals to 3. So I cannot use 25 here, I have to use the third second velocity because it's instantaneous and they want it at the third second. So when you write down the formula, you realize that you don't have the value for velocity. So strategy to get it is by using the formula for acceleration, but again you don't have acceleration, so the strategy to get it again is by using equations of linear motion. You have your final velocity at t equals to 5 seconds, you have your initial velocity which is equals to 0, and you have your time which is 5 seconds. So by subbing in the information, we would get that a, or my acceleration, is equals to 5 meters per second squared throughout the journey. Alright, next, ignore the power one first, focus on a. So we want to find the final velocity at t equals to 3, so sub in the information again. My a is equals to 5, my final velocity I don't know, my initial velocity is 0, my time is 3 seconds. So by doing that, just 3a, 3v would equals to 3a, and my a is 5, so v equals to 15. Now subbing in the formula for power, MAV 120 times 5 times 15, and we will get 9,000 watts, and that's the answer for this question. Alright guys, thank you so much. Adios.
Hai, untuk soalan nombor 6, PSPM 2021/2021, soalan 6, dia bagi graf, iaitu graf force displacement graph. So kat sini kita, kalau kita cari area under the graph, kita boleh cari works. So kalau saya dividekan into two parts, A dengan B. So dekat A akan dapat 10 joule, dekat B akan dapat 5 joule. So total works kat bawah ni dah ada 15 joule. Lepas tu dia bagi lagi, dia kata objek tu bergerak initial velocity 5. So kita cari kinetic dia, kinetic energy sama dengan 25 joule. Untuk final kita tak boleh cari sebab kita tak tahu final velocity tu V. So cara nak cari V, kita guna equation total works equals to 1/2 times 2 times V squared. Simplify, kita akan dapat V sama dengan 6.32 meter per second. Untuk soalan B pula, dia dah bagi beritahu objek kereta 1500 kg bergerak dengan constant force. Bila dia sampai initial velocity dia 20, dia ada maximum power dia 100 kW. Lepas tu velocity dia decrease to 10 meter per second. So soalan B Roman 1 dia tanya pasal constant force. So constant force kita boleh cari guna equation power sama dengan force times dengan velocity. So kita masukkan nilai yang ada untuk cari force. So force akan dapat 5000 Newton. Dan nombor 6 Roman tu, dia suruh cari work done to overcome the frictional force on the rough road. So daripada B Roman 1, kita tahu force dia ialah 5000 Newton, distance 50 meter, mass dengan velocity initial dengan final. So cara nak cari work done, kita guna work energy theorem, delta W. So delta W sama dengan delta K. So kita boleh, delta K tu ialah work done by the force and work done by the frictional force. So sekarang kita nak cari frictional force. So kita masukkan semua nilai yang ada. Work force tu 5000 Newton darat dengan 50 meter, tolak dengan frictional work. Itu yang kita nak cari, sama dengan delta kinetic energy. So kita akan dapat simplifykan semua, jadikan work friction itu sebagai subjek. So kita akan dapat nilai work friction ialah 475,000 joule. So itu ialah jawapan. Terima kasih.